So now that we've got a quadratic formula, let's use that to solve one of these equations. Because again, completing the square works. I could complete the square on that and get the answer, right? Divide everything by 3, move the 5/3 over, complete the square, do all the factoring and the square rooting and all that stuff, and I'll get my answer. But we just came up with a formula that says the answer to this problem is negative b plus or minus the square root of b squared minus 4ac over 2a. That's our formula. That's the answer. If we take a closer look at this formula, there are 3 specific components to this formula. There's a minus b, there's a 2a, and there's a b squared minus 4ac under a square root symbol. I want to get those separate. Let's see. Let's go black and change that back to blue. There we go. The green, the black, and the red are all specific components of the answer. Which of those is complicated?
Black.
The black part. A little bit complicated, right? Minus b is change of sign. 2a is double a number. Those are easy, right? b squared minus 4ac. Square a number, subtract 4 times the product of 2 other numbers. That one's a smidge complicated. Involves multiplying and subtracting. I don't know. 3rd grade and 2nd grade topics. So yeah, it's not too terribly difficult, but again, it's more complicated than change of sign and double a number, right? So of the 3 things, that's more complicated. So let's just take a look. First priority, again, if I'm going to use the quadratic formula, if these are my directions, this is exactly the structure I need. Because again, the quadratic formula was created from that structure. ax squared plus bx plus c equals 0. So when you create a formula, you have a type of structure it started off as. You need to make sure you're in that structure to use that formula, which we're at. So we're good to go there. I need to identify a, b, and c. A is whatever's in front of x squared, which is positive 3. B is whatever's in front of x, which is negative 2. And c is the constant, which is positive 5. Signs are important if you can use a quadratic formula. Positive or negative signs, and again, plus means positive, minus means negative for the sake of signs. All right? Once you've established these 3 facts about this equation, I don't even care about the equation anymore. That's what I needed to know. I'm going to start identifying some things. Minus b is change of sign. b is negative 2, so minus b is equal to positive 2. 2a is double a number. a is 3, 2a is 6. All right? And finally, b squared minus 4ac, that's the complicated one. I always do that one last. b squared minus 4ac equals. Now, the place people tend to mess up is this, b squared. Right? b is positive sometimes, b is negative sometimes. b squared is always positive. That object right there is always, if I can spell it right, always positive. Exclamation point. Pretend it's in bold print and capitalized and 15 exclamation. That's always positive. So what I do for b squared is this, 4. I don't even write negative 2 in parentheses squared. I just square it. 2 times 2 is 4. If b is 525, b is 636, b is 95, I'd probably type it in my calculator. 9,025. My calculator worked really well. All right. Whatever b is, you square it. All right? If it's an easy square, go ahead. If it's not an easy square, type in your calculator. But it's always positive, no matter what b is, positive or negative. Negative 2 times negative 2 is positive 4. Positive 3 times positive 3 is positive 9. So it doesn't matter if b is positive or negative. You just multiply it by itself. Minus 4 times a times c. A and c, or whatever sign they are, they're both positive, right? That's my structure, b squared minus 4ac. b squared evaluated, 4ac written as a product, subtracted. 4 times 3 is 12 times 5 is 60. 4 minus 60 is negative 56. Okay, so what I do is I just take each component over there and I figure out what those 3 components look like, right? Then I come back over here and I simply create that same structure. Something plus or minus the square root of something over something, right? That's the structure we're looking at. And I just substitute those numbers where they belong. So b, minus b goes right there. 2a goes on the bottom. B squared minus 4ac goes inside the radical. And just like that, we have our answer. It's not simplified, but that's our answer, right? Our final step then is to simplify our answer. First thing I notice is a negative in the radical, right? So I'm going to make it a positive, and I'm going to make an I come outside. The other thing I notice is 56 is 2 times 2 times 2 times 7. Right, 56. So that's 2 times the square root of 14. That's prettier than the square root of 56, right? So I'm going to get x equals 2 plus or minus 2i times the square root of 14 over 6. And my final step then is to divide, reduce if possible. 2 and 6 all divide by 2, so I'll do that. The other thing I would probably do personally, I'm not going to count it wrong if you don't do this. If I get an imaginary, I like to separate them. So 2/6 is 1/3, plus or minus 2/6 is also 1/3, so the square root of 14 thirds I. I like it separated, but if you put 1 plus or minus square root of 14i over 3, I'm not going to count it wrong. But that's how you do it. That's using the quadratic formula. It skips all the completing the square steps. It gets us directly to the answer in one step. You find out all this information, throw in the numbers, all of a sudden you got your answer.